Okay, class, so this is part 2 of chapter 7, and we're talking about CVP analysis. And so again, this is in case we don't remember where we're at. We're in chapter 7. This is part 2. This is where we left off. And this is just a table that explains how we're going to do a break even for a multi-product company, which most companies are multi-product. And by the way, this would be done by a computer. But just a reminder, as we calculated the ratio, which was a 5-to-3 ratio for regular and large posters. So just going back, remember this is K's posters. And then we took and divided it, the 160, which is the contribution margin, by the 8. We came up with a weighted, and the key word here is weighted average contribution margin of 20. So moving on, now we want to take a look and see what is the break even. And of course, break even's when your operating income is 0. So we're taking the same break-even formula, shortcut formula that we had for one product, and that is we take the fixed expenses plus, in this case, because we're doing break-even, 0 operating divided by the weighted average contribution margin. So weighted average contribution margin from the table. And so very simply, to break even, we have to sell 350 posters. Now, we still have to one more step here, and that is of the 350 posters, how many are regular posters and how many are large posters? And so you just multiply it by 350 times 5/8 and 350 times 3/8, and here's the number of regular posters and large posters. And of course, typically speaking, we would round off because you wouldn't make 3/4 of a poster, but it would be 219 regular posters. Now, we're going to now look at the weighted average contribution margin ratio. Okay, so the first time we did a unit contribution margin. Now we're doing the margin, and that's just simply going to take the weighted average contribution margin of 160 and then go divide that by 385, which again is the selling price. And we did the selling price using the ratio, the same as we did for the contribution margin. And so our contribution margin ratio is 41.56%. Now, why do we do that? Well, the contribution margin ratio is what tells us what the break even in sales dollars is. Okay, so we use the contribution margin unit to calculate the number of units. We use the contribution margin ratio to calculate the sales dollars amount to break even. Now, going to the next topic, we have certain common risk indicators. Okay, and there's many factors that go into this: the general health of the economy, the industry of operation, the current volume of sales, the fixed and variable costs. Those all go into the risk. And we have two ways of dealing with these risks, and they help us predict and make future decisions. And the first one is something called margin of safety, and the second is called the operating leverage. Margin of safety is simply the excess of the actual or expected sales over the break even. Okay, so a drop in the sales company can be absorbed without incurring a loss. In other words, how much in sales can you lose before you're at break even, and then you start losing money? Okay, the higher the margin of safety, of course, the less risky. So if you're investing or if you're a manager of a company, you want to know what your margin of safety is so you know how much you can absorb when you're taking risk. For Kay, she's expected to sell 950 posters. The break even is 500 posters, so her margin of safety is 450 posters. The calculation is relatively easy. It's understanding what it means, which is a little bit more difficult. Okay, so you can also look at it in sales dollars, where the margin of safety would be, if we're going to sell 950 posters, we would have $33,250 in sales. And of course, here's the amount we calculated using the contribution margin ratio for the break even in sales dollars. Margin of safety then is $15,750. Now you can also do margin of safety as a percentage. Okay, and that's just taking whatever the margin of safety in units was, which we calculated back here in the previous slide, divided by the actual or the expected number of sales, and this gives us our margin of safety as a percentage. Okay, and you can do it both in units or you can do it in dollar amounts. Okay, notice anytime your numerator and your denominator has the same unit, it comes out as a percentage. Okay, these are both dollars, and so dollars cancel out, you get a percentage. These are posters, you get a percentage. Okay, margin of safety, extremely valuable when you're looking at risk factors. One other risk factor then is the operating leverage and operating leverage factor. Okay, so this has to do with the relative amount of fixed and variable costs that make up your total costs. The more fixed costs you have, the higher the operating leverage. And that's because fixed costs has a greater risk to it. In other words, let's say that we're in the agriculture business, and we can either have machines that do most of the picking of the agriculture, or we can use cheap labor. Well, if we use machines and we have a flood, or if we have a drought, or if we have something happen in the economy, we still have to pay on those long-term assets, the machines that pick the crops. If we have a bunch of day laborers, we simply don't hire them. Okay, variable costs, there's not much risk to it. So this sets up something called the operating leverage factor. Okay, and it's how responsive a company's operating income is to changes in the volume at a given level of sales. The calculation for the operating leverage factor is contribution margin divided by operating income. The greater the operating leverage factor, the greater impact the change in sales has on operating income. Okay, so the operating leverage and operating leverage factor indicates the percentage change in operating income that will occur at 1% change in volume. Okay, so the lowest possible operating leverage factor, and we'll use the OL as that, is 1. And that's where your contribution margin is exactly the same as your fixed costs. Okay, so now in an example, assume that K sells 950 posters. And so just bringing out the math, here's our contribution margin, here's our fixed expenses, here's our operating income. Again, contribution margin is the numerator, operating income is the denominator, and our operating leverage factor in this case is 2.11. So that means for every 1% change in the volume, we will have a 2.11% change in the operating income. If we had a 10% change in the operating volume, we would have a 21.1% change. I should say if we had a 10% change in the sales volume, we would have a 21.1% change in the operating income. So this tells us that when you have high operating leveraged companies, that you have higher fixed costs and lower variable costs. As I mentioned, companies like agriculture typically have low operating leverage. Companies like an airline have very, very high operating leverages because most of their costs are in airplanes, long-term fixed cost airplanes. So you have a higher contribution margin ratio. So companies for high operating leverage, company changes in volume significantly affect operating income. Sorry about that. You have high risk, high potential for reward. For example, golf courses, look, lots of fixed assets. Hotels, lots of fixed assets. Rental car agency, theme parks, airlines, cruise lines. And so when the pandemic happened in 2020, all of these companies suffered great losses because their fixed costs were much higher than their variable costs, high operating leverage, which means a very high drop in their operating income. Low operating leverage, higher variable costs, lower fixed costs, lower contribution margins. And so the volume does not have a significant effect on operating income. There's a lower risk, but there's also a lower potential for reward. So merchandising companies and fast food restaurants, yes, they're not going to do as well when the volume drops, but notice that merchandising companies simply don't buy as much merchandise. Okay, they don't have it. If their stores closed, like during the pandemic, they still sold some things online and they still had to pay for if they have a store. But companies that are totally online, they don't have hardly any fixed costs. And so all of their costs are variable costs. Not all of them, but a lot of them are variable costs. Fast food restaurants, same situation. Okay. Yes, they can lose money, but for the most part, if you close the doors, you can still have drive-throughs. So you have to know which industry you're in, and then you can estimate, like, what is my operating income going to be next year if there's a rise in sales volume or if there's a drop in sales volume. So do the homework problems on operating leverage to really get a better idea of what this means. Now, the last slide for this particular chapter is choosing a cost structure. In other words, do we want option 1, where we use variable costs as 10% of sales revenue, where, in other words, $3.50 per poster, and our fixed costs are at $300, or do we want to use it where there's $1,000 fixed cost, but we don't have any kind of variable cost? So we could choose, and this would be like if you totally automated something versus if you used people who are wages. So at what point is this an equal option? In other words, what is the point of indifference? So we would have to determine how many units do we have to sell using these two options where it's indifferent. Well, you can see there's a formula, and it basically says this: the number of units times the variable cost per unit plus the fixed cost equals the number of units. Here there's 0 variable cost plus the fixed cost. So if you just solve for this algebraic equation, you find that if you sell 200 units, you would have the same or an indifference between option 1 and option 2. Okay, now you can go ahead and do the calculation. If you sell more units, then option 2 is better. If you sell less units, option 1 will be better. Okay, so in this case, this was a leasing option. Okay, class, bye for now. See you when we get to the next chapter.